video will quickly run through some model problems in your notes. I'm going to start on page 11 with an order of operations problem, and then I'm going to do a proof on page 13. Let me give you some of the answers. Number 1 is 36, and number 3 is -4. Number 4 is 29 over 4, and I'm going to work through number 2 step by step. So using order of operations, number 2 is not that difficult, but I do want to talk through it. Okay, 4 raised to the power of 3 is 64, and then I'm subtracting. And this is the absolute value of -8. The absolute value of -8 is +8. And the subtraction sign in this problem is the subtraction sign that was before the absolute value bars. And now moving on, I'm going to multiply times 6, and I'm going to change this last expression into a multiplication problem and express it in this way. So now I'm going to focus over here using my order of operations. I'm going to have 64, and I'm going to subtract 48. I'm just going to go left to right. 8 times 6 is 48 times 1/16, and I'm going to end up with 64 minus 3 for an answer of 61. Next, I'm going to move to number 5, which is a little bit more complicated. And I'll give you the answer for number 6. Number 6 is simply 4. And now let's work through number 5 together on the video. So I have a lot of steps in number 5 and a lot of clutter in this problem. So the first thing to do is to make sure that you understand where the grouping symbols are. So this entire numerator is bracketed together and it's going to be squared. So I'm going to do this in pieces. And then here I have a set of parentheses inside that. So the parentheses are going around the terms that are expressed like this. So make sure that your notes clearly reflect where the grouping symbols fall. And now I'm going to do this piece by piece. So here's my numerator. I'm going to start with the 15 and I'm going to subtract. And first thing I have is an absolute value bar. So I'll do this in green. I have the absolute value of -6 plus 2. Well, that's going to be the absolute value of -4. So I'm going to express that in this manner right here. And then I have plus the square root of 9. Well, the square root of 9 is 3, and I hope that that's something you're all comfortable with. We will study radicals at some point this year. And now my grouping symbol closes, my first parenthesis closes, and now I have my large grouping symbol on the outside, and I will square the whole thing. But I have to do this in stages. So I'm going to copy again. I'm still just focusing on the numerator. I'll pick up the denominator once I get the numerator all cleaned up. So now I'm going to have 15 minus, and let's see what's happening inside the parentheses. The absolute value of -4 is going to be +4. And I'm going to have plus 3. Closing that grouping symbol, and then I have the large grouping symbol, and then I have the exponent 2. So the numerator is starting to take shape. It's looking a little bit better. So my numerator really just kind of whittles its way down to 15 minus 7, and I'm going to square that entire value. So that means that I'm going to have 8 squared is my simplified numerator. And now let's pick up the pieces of the denominator. So my denominator is 3 minus 3 cubed. Well, let's do a little scratch paper work. 3 cubed is telling you to multiply 3 times itself 3 times. And that gives you a value of 27. So moving to the next step, 8 squared is 64. And 3 minus 27 is -24. And now I need to simplify this. You can think of 64 as 8 times 8. And you can think of 24 as 8 times 3. And of course this is negative, so I will have a negative sign remaining. The 8's divide away, leaving behind a +1. So your simplified answer is -8 over 3. And I'll let you try the others. I'm now going to move to page 13 to model one of the algebraic proofs for you. I'm going to do the first proof, and I'm going to get the whole thing on the screen. All right, this is much more work than you would actually show when you're solving an equation, but keep in mind that you've internalized many of these steps, and this is really what you're doing every time you solve an equation. So this is a good place to start the year, just reviewing some basic properties or basic skills using the properties. So every proof usually starts, or almost all proofs, start with what's called given. You have to have a fact or something given to start with. So the first reason is given. And what I'm going to do is justify each change as I go down the chain of this proof. The first change has occurred right here. I've written -5 as plus -5, and that's using the definition of subtraction. Moving from the second step to the third step, I'm distributing the 4, so I've just simply used the distributive property. Using the distributive property. Now, in the next step, what's happened, I'm adding +20 to both sides. So this is the addition property of equality. And I'll just write add, sort of shorthanding this, and then POE for property of equality. I'm adding the same thing to both sides. And then in the next step, I'm adding -20 and +20 together, and I'm replacing that value with 0. So what I've used here is the additive inverse property. Inverse property of addition, however you choose to say it, additive inverse, or if you like, you could say, I'll give you an alternative in red, you could say inverse and the initials POA for property of addition. You have a choice, you can do either one, you can justify it either way. Okay, moving on down, now what I'm doing, 4x plus 0 is now simply being stated as 4x. And what this is the additive identity property. Anytime you add a number to 0, you get the number right back. So that's called the additive identity property. And now in the next step, I'm expressing 6 plus 20 as simply 26. So this is a substitution. Okay, looking at the next step, what's happening here? Both sides of the equation are being multiplied by 1/4. So the property that I'm using here is the multiplication property of equality, and I will use abbreviations once again. Since I'm multiplying both sides by 1/4, it's a property of equality in the operation of multiplication. And now, moving to the next step, what's happened, you see I've got grouping symbols here, and I'm regrouping. I'm now going to put 1/4 and 4 together. So I'm just going to call this the associative property of multiplication, and I'll use a capital M for multiplication. Now moving to the next step, I'm going to take the product of 1/4 and 4, which is just simply +1. So this is the multiplication property. Let's see, this is inverse, the inverse property of multiplication. And once again, I'll use the initials POM. 1/4 times 4 is being replaced with 1. So that's the inverse property of multiplication. And now in the next step, I have 1 times x, and I'm going to express that simply as x. And this is your identity property of multiplication. Any number times 1 is that number itself. And once again, I'll use POM for property of multiplication. And then finally, I'm taking the product of the two numbers here, and I'm going to replace it with the fraction 13/2. And this is a substitution. So I would like for you to try on your own, try to mimic this, and just keep in mind that this is really what you're doing every time you solve an equation. You've just simply compressed all the steps in your brain so it doesn't seem like you're doing quite this much work. This is a good place to start the year, just reviewing this, making sure that you've got every single step straight in your brain.